Today's guest is the mathematician Edward Frenkel. His story takes him from climbing fences and sneaking into math lectures at a Moscow university, all the way to the hallowed blackboards of Berkeley. It's the sort of story that one might write a book about. In fact, Edward has written a book about it. And today, he's sharing the journey with us. Where were you born in the world? Not America, I'm guessing, from your accent.
Yes, you're guessing right. I was born in Russia,
Yeah.
Soviet Union at the time.
Soviet Union at the time. Whereabouts? Is that a place I will have heard of?
A little town called Kolomna.
Kolomna. Where's that?
Near Moscow.
Like how far out? Like,
117 kilometers. You can Google how many miles that is. But
Okay.
I guess about 70 miles. One of the good things about growing up in the Soviet Union was that science was highly respected. And in particular, you could find books, popular books about science in the bookstores. And so that was something that really excited me as a kid, as a teenager. I was reading mostly about physics. I was really excited about quantum physics, things like elementary particles and forces of nature and the universe. And there were lots of books. Some of them were translations, but some of them were local by Russian Soviet authors, and they were quite good.
What was it about the culture of the country at the time that would have made science like so revered?
Well, two reasons. First of all, the nuclear bomb and research related to that, as well as space exploration. The Soviet government knew that they needed scientists, good level scientists. And so, therefore, there were opportunities in that area. And second, everything else was controlled by the ideology. And so, for instance, if you wanted to go into social sciences or humanities, you kind of knew that you would have to be constantly giving praise to the Communist Party and the great leaders and so on. And so it would be very difficult, and everything would be censored, and everybody would be looking over your shoulder all the time. So in those areas, you could not possibly have the kind of freedom that you could have in mathematics or theoretical science. Experimental science, yes. For instance, genetics was ostracized and people were jailed and so on because it kind of was connected to agriculture and stuff like that. So that's where politicians thought that they had some sort of authority. Stalin actually went as far as writing a book about linguistics, as a result of which a number of people were jailed and so on, so a lot of people suffered.
Right.
But he never made any pronouncements about mathematics. So he knew not to cross that line. So it was lucky for mathematicians. So in other words, mathematicians were given relative freedom within their profession. Of course, as soon as anybody dared to say anything political, they would be persecuted and so on. Like Sakharov, for instance, is a famous example of a physicist who was one of the leaders of the nuclear project, and yet he was exiled. So he almost untouchable, but it was exiled actually.
Ed, are you saying that as a boy, like as a young boy, where you're not totally as engaged with that side of things that much?
Yeah, so I didn't know all that, of course, at the time.
Yeah, but are you saying that even at that time, the authorities encouraged lots of books and stuff about science because they wanted to recruit?
You want to recruit kids,
Yeah.
talented kids, to go into physics and so on, and math, because they knew it was important for the industry and for the weapons, for defense.
But that is at least that's showing some foresight and not just thinking about the now.
So that was actually one of the good things in some sense.
Right.
And also kind of a respect. There was this sort of attitude where not necessarily revered scientists, but they were respected. And there were movies about scientists, kind of romanticized. They were romanticized, these people who are spending, at night in front of a blackboard, arguing, smoking, this kind of stuff. There were movies like that. And that must have influenced me a little bit. But what really excited me was the subject itself. So I was just drawn to this hidden reality, to this magical world of fundamental structures of the universe. Like, what is this all about? What's going on? What's really going on beneath the surface,
Were you really good at it? Like, were you top of the class? Were you like the
Yes.
Right.
I was a kind of a straight A student, so school came easy to me.
Was it mathematics that was your number one, or were you also interested in literature or physics or chemistry, or was it always going to be math?
Interesting enough, so I was interested in literature and art and so on. But actually math was my least favorite subject. I hated math. That's maybe too strong a word. I did not like what they were teaching us at school. It came easy to me. I could solve all the problems.
Yeah.
But I was under the impression that what school mathematics was, what was presented to us in our classes, was exactly what real mathematics was. Maybe problems would become a little bit more involved and so on, basically along the lines of, Euclidean geometry and some equations, quadratic equations and so on, and some kind of simple manipulations with functions and derivatives and integrals. And I just thought it was trivial and kind of pointless and boring and stale.
But easy.
And irrelevant, but easy, yes.
Right.
So physics was my subject. That was the most exciting subject, because there were all these crazy particles like quarks,
Yeah.
And also I was reading about people who were making those discoveries. For instance, one of my heroes was Lev Landau, who was actually a Nobel Prize winning Soviet physicist who worked in quantum physics and made some important discoveries. He was a student of Niels Bohr, who was one of the fathers of quantum mechanics. And he was a very interesting guy. So there were books written about his life. By that time he was dead, but there were fascinating books written about him. So I had all his biographies on my bookshelf. I had a little photograph. So I took a picture with my little camera. I took a picture of a cover of one of the books, and then I printed that picture. And I had this little photo on my desk.
So instead of like a famous footballer or a Hollywood star, you had this...
I had this guy. So actually I had this guy, I had Niels Bohr, and I had Albert Einstein.
Right.
Albert Einstein, perhaps a little more cliche, but
yeah.
Bohr and Landau were my heroes as well. And so I thought those stories were fascinating, how these people were making these discoveries, which was just astonishing. And so went so against common sense, I would say, like the kind of phenomena of quantum physics are really so surprising when you first look at them.
You're a schoolboy. Your heroes are these physicists. You're very excited about physics and this mysterious world of particles and quantum mechanics. Mathematics at this point seems like a bit mundane.
Boring.
Yeah. What happens that switches? Because obviously you're sitting in front of me as a mathematician.
Yes.
What switched? Why did you change streams? What happened? Something happened. So there was an event. There was a singular event, which is very interesting to me as a kind of a metaphor for a lot of things. So how much we depend in our lives on our teachers, on our mentors, or people we encounter, which it may appear at first glance that it's a kind of a chance encounter, but how consequential it may turn out to be. I just turned 15, and I am just about to enter last year of my high school, and my mother meets this guy on a bus or something, and on a tram, whom she had known for many years, but had not seen in a long time. And he is a mathematician. So I lived in this town, this little town, population 150,000, industrial town. It was not particularly exciting in terms of science education and so on. But there was one little college which prepared teachers. So it was called pedagogical college, so pedagogy. So they were teaching, students who would then go on and become school teachers. Teaching the teachers.
Teaching the teachers. And this guy was a professor of mathematics at this college, and he had a name which could come directly from Tolstoy's novel Yevgeny Yevgenyevich. It was a patronymic. The first and patronymic Yevgeny Yevgenyevich Petrov.
Okay.
So he was actually remarkable man. So in fact, he was sort of out of place there, because he's brilliant. He's a brilliant guy. What is he doing there? So of course, there was also a backstory for that, as I found out much later, that there was this famous mathematician Rokhlin, topologist, who was basically unfairly treated by Stalin regime, and he was exiled to Siberia and was almost killed, executed. But because his friends pleaded, to release him, he was not allowed to go to Moscow or St. Petersburg, but he was allowed to live in my hometown, Kolomna,
right,
where he stayed for a few years as a professor at this institute. It was during that time that my teacher was a student in that college.
Okay.
So you see, this kind of like this.
Okay.
This
So he'd
lineage.
He'd identified and trained up this promising student
Yes,
he had. Right?
who most likely would have been lost, and would not have been able to express themselves fully or achieve their greatness.
Okay.
There were a number of people. There were several others who were also from that period, and then they stayed on and became professors of that university, of that little college.
So this one guy who'd been exiled there became this kind of seed for mathematical greatness
In my hometown.
In this
and it
teaching
could have
college.
been any other town, right?
Okay, right.
So it was literally a provincial place in the middle of nowhere.
How was it? I didn't ask what your parents did. So how was it that your mother came to be friends with this accomplished mathematician herself?
So my parents were engineers.
Right.
But of course, so there are more layers to the story, because my father wanted to become a physicist, quantum physicist, and he was denied entrance to university because his father was arrested and put in Gulag by Stalin, so in 1954.
Right.
And so my father actually finished high school with honors. And was not, and at that time he was supposed to be admitted automatically to university, and he wanted to become a physicist. But because he was the son of the enemy of the people,
It's like a black mark on his record sort of thing.
yes,
Right.
so he was not admitted.
Was that, well, I'm sure we'll come to this, but the thing that comes into my head, does that black mark go down 2 generations? Is that going to affect you later on? But I'm sure we'll get
guess
to
what?
We'll get to that.
These kind of things have a tendency to repeat themselves.
Okay, we'll get to that. We'll
Right?
get to that.
So that was important somehow for me, I think, unconsciously at least. So now I kind of see it more clearly that in many ways I was fulfilling my father's dream. So we talked earlier about my interest in physics.
Yeah.
And of course, I knew that part of the story, that he wanted to do physics, but he was unable to. And so he basically had to go to this engineering college. And then he kind of gave up. He kind of didn't really try to pursue that dream that he had.
Becoming an engineer seems like quite a
I'm
prestigious...
not to disparage in any way the profession of an engineer.
Yeah. What kind of engineers were your parents doing? Like, what kind of engineering were they doing?
Oh, my father was an electrical engineer.
Right.
He was basically sent to this, provincial town and he thought he would just go there for 2 years and then try to find a job in Moscow, like in a big city. And that's when he came and he met my mother. So,
Change of plans.
Change of plans.
Yeah.
And it's fascinating to see all these twists and turns.
Yeah. So your mother has friends with this mathematician somehow?
Yes, but my mother knew him because she played volleyball and this guy played volleyball. So they used to play volleyball together.
Okay. So your mum bumps into this guy on a bus or on something like that?
Yes.
Okay.
And she's, oh, how are you? And they start talking, and of course, immediately my mother starts telling him about me, because that's what she was talking about. Would talk to anybody about most of the time.
Proud of herself.
I was proud. She was proud of me.
Were you the only child, or?
No, I had an older sister.
Okay,
but she was already an adult and so on, and so I was still in high school. So it was kind of exciting.
So she was probably saying, "Oh, my son's really talented."
Yes, and this guy's eyes light up, right? Because he's in this college where, frankly, there were probably not so many brilliant students, and so he's on the lookout for somebody that he can talk to, and he says, "Oh, I want to meet him." And my mother says, "Sure, but I have to warn you, he hates mathematics."
Okay.
You see.
Okay.
And so then she comes home and says, "There is this guy, Evgeny Evgenyevich, who wants to meet you. He's a professor of mathematics in this college." And by the way, this college was literally 5 minutes walk from my house. And so, but I was this kind of pouting teenager, so I was like, math. Don't you know that I hate math? I didn't want to go.
No.
But she convinced me that it was sort of like it would not be nice she made an appointment. So I have to go at least once and talk to this guy, and then afterwards, whatever. If I don't like it, I don't have to go again. And so I said, okay, fine. And that was the fateful encounter.
That meeting did it.
That meeting kind of changed my life.
What did he do? What did he show you?
What did he do? He's a very clever guy. So I come to his office, and he has this lots of books on the shelves, right?
Yeah.
So but he already knew. My mother told him, he doesn't like math, and says, okay, what does he like? So physics. So theoretical physics, elementary particles. So Evgeny Evgenyevich had advanced information, and he used it wisely. So when I came, he asked me, so I hear you're interested in quantum physics, so what do you know about it? And I said, well, I've just been reading this book about quarks. And it's elementary particles, which physicists theorized would our constituents of particles which previously were thought to be indivisible, protons, neutrons, etc., and yet turned out to contain these little smaller pieces. And I was very excited about it. And he said, oh, okay, cool. And do you know about the representation theory of SU3? And I'm like, what? SU what? And he says, you don't know SU3? Then how can you possibly understand quarks? So he hit a nerve in the following sense, that I was frustrated by the fact that in those popular books that I was reading, they presented this nice narrative, nice captivating story, but they never explained the details. Like, how did physicists actually come up with these ideas? It sounded mysterious, and I was longing for an explanation. So then Evgeny Evgenyevich, at this point, he pulls out this thick book from the shelf, and he opens it somewhere in the middle. And I could see the diagrams, some of which would be in the popular books, but they wouldn't explain what they were.
Yeah.
But here, in this book, it was clear that these diagrams were part of a theory, of an explanation, of an actual explanation with formulas and equations, which I couldn't make heads and tails of at the time, right? And then Evgeny Evgenyevich pointed to those pictures and formulas and said, you think what they teach you at school is real math? No, this is real math.
Right.
Right. I was like, I might have as well been struck by lightning. It was just like one of those moments. It was like, my God, there is this thing which I had no idea, that exists, and obviously holds the answers to all those questions that I wanted to find.
But what happens now? Because teenage you now just has to go back to high school where you're just being taught basic mathematics, and you're not getting access to all that stuff. So how do you get access to this thing you've just seen?
So exactly. So I was like, how do I learn all this? It looks complicated. And he says, oh, it's okay. I can teach you. I can see you're a bright kid. So if you want, you can come and talk to me every week, and we'll figure it out. I will explain it to you. Wow. That was so exciting.
So he became like a private tutor?
Yes.
Right.
Once a week, I would go in the evening, and sometimes we would just stay late till 9 or 10. Once we were locked in an auditorium by a custodian who didn't even bother to check whether there was anybody in the room. Yeah. And so we had to. Luckily, it was on the ground floor, so we could get out through the window. But it was very funny. Yeah. And so he gave me book, but he said, we can't jump immediately into this stuff. You have to first learn the basics. So he gave me a few books. There was a book about linear algebra, for example. So that he said linear algebra is the basis of all of mathematics. Interesting enough, right now I'm teaching a big class at Berkeley of linear algebra, which I have taught many times. Yeah. But I was like, yes, you have to learn this. This is absolutely fundamental. Then there was a book about number theory. There was a book about topology, which is a branch of geometry, which probably your listeners know about. You must have done a bunch of videos on Numberphile. And then I would read those books. I would come, and he says, okay, what did you read? And tell me what you read. You have any questions? And we'd discuss, And some night I wouldn't sleep. I would have sleepless nights just thinking about this stuff. It's like, wow, it was just like a new world.
Yeah.
And in a way, it was an escape also. It gave me this escape from, because, this Soviet Union was starting to deteriorate. We're talking about the early mid-80s. So we're talking about just before perestroika started and the Soviet Union collapsed. And so it was kind of like depressing in many ways to be in the country, to live there at the time. But then there was this magical, beautiful world, and I didn't have to go anywhere to find it. It was right at my fingertips. It was just really marvelous.
How was this advanced, inspiring education you were getting once a week meshing with still having to sit through boring math lessons at school.
Well, I had a newly found appreciation for this stuff because now I could see that through the lens of this sort of higher math that I was learning, and it actually made a lot more sense. I could see that it wasn't boring. It's just that it was kind of elementary, and the teachers themselves, they were not, they did not know how to explain they were not properly educated themselves to be able to make the connection to some other things which would pique the interest of the students, you see. But the subject themselves were fascinating, actually, if one could see them from a slightly higher vantage point.
At what point does this like new appreciation of mathematics, because I imagine this new appreciation of mathematics is also enhancing your enjoyment of physics, because it's helping you understand the physics more deeply. At what point does kind of mathematics overtake physics and you start thinking, I don't even want to do physics, I just want to be a pure mathematician now?
Very quickly. I mean, and he was clever because he wasn't putting it as a question of substituting one subject with another. He said, if you want to understand theoretical physics, especially quantum physics, you have to have a good understanding of math because it's all based on math. So before that, you cannot really do physics. He said all these physicists who theorized all these beautiful theories that you heard about or read about, they did that based on sophisticated mathematics. And it was very convincing because he showed me those books and so on, right? So I was like, okay, then I have to do the math. But very quickly, I discovered that the math that he was talking about was actually very interesting in its own right. So I became very curious about that, even not necessarily because of its connection to my original interest, but just because they were so exciting things. But they were hidden from me until that point. They were kind of veiled, and then suddenly the veil was lifted, and I was like, okay, look at this, look, there's this, and I was like, okay, this is great. So my hands were full with that stuff.
Do you remember a branch of mathematics or a theorem or a field that you were taught about at this time that's a really exemplar of, oh my goodness, where did this come from?
So there was this one thing which I found absolutely incredible, and that's called p-adic numbers. So it's a P, and then there is a little hyphen, and then adic, A-D-I-C, p-adic numbers.
Yeah.
So it turns out that in addition to the numerical system that we are used to, such as, let's just say real numbers. So real numbers, right? So meaning real lines, so all the points on the real lines, including 0, 1/2, pi, e, square root of 2, golden ratio, and so on, right? So that's real numbers. So it includes all rational numbers, which are ratios of whole numbers themselves. But it turns out that there is sort of a parallel world to the world of real numbers, and that's the world of p-adic numbers. So p here is a prime number. So it could be 2, 3, 5, 7, 11, etc. Let's fix a prime number. Let's say 5. Then there exists this five adic numbers.
Okay.
There is this collection of numbers. It includes rational numbers, just like real numbers include rational numbers.
Yeah.
But they have totally different properties. So what do I mean by numbers? So they form these numbers, p-adic numbers. They are elements of the set which have fundamentally properties very similar to the properties of real numbers. You can add them together, you can multiply them. There is a 0 element, there is an element 1, there is a negative for every element, and then there is a multiplicative inverse for every non-zero element. So it's what mathematics call a field. And it contains rational numbers. And in a certain sense, it's a completion of rational numbers, the way real numbers is a completion of rational numbers. But it has totally different properties. So, for instance, whereas a real number you can write in decimal form, where each digit after the decimal point it represents a piece which is smaller and smaller. So, for instance, if you have something 0.1, it means like 1 over 10. Then it's 0.01, it's 1 over 100, right?
Yeah.
So, and so on. It becomes exceedingly smaller.
Yeah.
But the p-adic number, a 5-adic number, so p is, let's say p is 5, p which has to be a prime. We can choose p to be 5, which is a prime. Then we have these 5-adic numbers. And the 5-adic number, each next number is bigger. So 0.1 would be 5. 0.01 would be 25, and so on. So the convergence property is exactly opposite. It's like you have a binocular, but you reverse the binocular. So the notion of distance for these numbers is reversed from the notion of, it's kind of reversed from the notion of distance for real numbers.
How have we not done a Numberphile video about this yet?
I don't know. Okay.
that could be next on our list.
All right.
So that was an example of
So
something.
that, I actually remember how, when I first read about it and I tried to understand what these numbers look like, it looked so counterintuitive. And I was reading, so this was, I read, there's a very nice book about them, which my new teacher, my mentor, Evgeny Evgenyevich gave me. And I remember I could not sleep all night long just thinking about it. How is it possible that this thing converges, even though it doesn't converge?
Yeah.
You see?
Yeah.
So that was one thing which really stood out. That's one concept. And it kind of helped me to see this hidden side of mathematics. When I say hidden, I mean from the point of view of a student who just goes to regular classes in high school or whatever, where normally they don't talk about this stuff. This sort of really ideas, this kind of like outrageous ideas, like really crazy, like wow, exciting ideas which are very counterintuitive, captivating things. So this was to me like an epitome of that.
Take me to the end of school then. Like what happens is you come to the end of high school. You're still getting obviously excellent marks at school and things like that.
Yes. And I'm super excited about all the stuff. And every Monday, whatever it was, I don't remember which day of the week, I would go and meet with Evgeny Evgenyevich. Yeah. And so then it becomes clear, so this is my last year of high school, it becomes clear that I want to be a mathematician.
A lot of people who I've spoken to who are mathematicians now, when I speak to them, they always say to me, when I was at high school, I didn't even know what a mathematician was. I didn't know it was a job. But it sounds like because of your exposure to Yevgeny, you did know what a mathematician was.
Right. And he was, he was actually looked like a mathematician too in some sense. So he had these thick glasses. I was wearing glasses at the time too, by the way. Okay. I was a totally nerdy kid, And he was wearing glasses, and he was a chain smoker also. Not necessarily a good thing.
No.
But and he was just this guy, very smart, and he always had this stubble of a beard,
Did you want to be like him?
So in some ways, I guess I wanted to be like him. Yeah. Yes. So he fit the profile,
Yeah. Okay. So you're at the end of high school. I want to be a mathematician. What do you do next? How does this happen?
So I talked to him about it, and he says, "Look, there is basically only one place in Moscow. First of all, I would have to go to Moscow. Obviously, not applying to this little school, this little college. There was not much opportunity after that. Getting a diploma, even though remarkably it had a professor like that, so it wouldn't be such a bad thing necessarily. But I was shooting sort of for the stars. So, okay, I want to go to Moscow, which was not that far away.
Yeah.
And Moscow had the best schools in the Soviet Union, also St. Petersburg, which was much farther away.
Yeah.
Okay, so the only place where you could study pure mathematics, not applied mathematics, in other words, mathematics in connection to some real-world problems, specific problems, but pure mathematics, just for the sake of it, so to speak, which is what I had been studying for a year by then. That place was Moscow State University. And was this grand building, like 60 or 70-story building, beautiful in Moscow, which I had seen on postcards, and I had seen it when I came to Moscow. And so it's clear that I have to apply to that. It was the Department of Mathematics and Mechanics, and that's where all the best mathematicians of the Soviet Union worked.
Okay, so you applied.
And I applied, yes. And interestingly enough, the year was 1994. I'm not making this up. So the readers of George Orwell will see the parallel.
Okay.
This is the last year before Perestroika. So Gorbachev comes to power in 1985, and the Soviet Union starts changing. First slowly, then faster and faster, and then to the point where in 91 it disintegrates and collapses, right?
Yeah.
But this is 1994, and it's exactly the quiet before the storm. So when the total stagnation, everything is controlled by the party apparatchiks and the ideology and so on. And one of the consequences of that, unbeknownst to me, because I'm 16 years old at the time.
Yeah.
When I present myself to the exams, the entrance exams.
Yeah.
Unbeknownst to me, in Moscow University, they had this sort of a cabal of anti-Semites, these professors who kind of completely controlled the admission process.
Right.
This happened. There is a bunch of articles about this that had been published in recent years. Apparently, it all started in the 70s. So by then they were deeply entrenched for about 10 years, these people. And they completely controlled the admission process. And they had a very sophisticated system in place to fail students who had anything to do with Jewish nationality. Not religion, mind you. So it's very interesting because in the United States or in Europe, when people say Jewish, it usually means in a religious sense.
Yes.
But we are talking about the Soviet Union, where religion was all but non-existent.
Yeah.
My father was Jewish by blood, not by religion. So he was an atheist, actually. And his parents were not religious either. And my mother was Russian. And the only religious person in my family was my maternal grandmother. And she was an Orthodox Christian. Okay. So she actually went to church.
Right.
And she would cross me before my exams, so that was the only exposure to religion.
Yeah.
But the authorities tracked nationality. They call nationality, so it means by blood. So, for instance, everybody had a passport, internal passport, where they would put your first name, patronymic name, last name, date of birth, and then number 5, the fifth line would be nationality. And so, in my case, the nationality was written as Russian. One parent was Russian, was deemed to be Russian, the other parent was deemed to be Jewish. So I could choose. Right. But my last name clearly sounded Jewish.
Right.
And in fact, my father in his passport had Jewish as nationality.
I know you weren't aware of this discrimination that was happening, but were you very aware of your Jewishness? Like, would you have known, oh yeah, my dad has Jewish in his passport? And
that's a very good question. So when I first found out, I was shocked.
Right. So it wasn't part of your upbringing?
Not at all.
Yeah.
My father had no interest somehow in language or culture, which is not necessarily a good thing. But in the Soviet Union, it was kind of dangerous to venture into those territories. And there was a lot of, unfortunately, anti-Semitism at the kind of domestic level. Kind of like I'm sure that some parents would make remarks to their kids. So there was this sort of in the air. It was sort of in the air. So when I was about 11 or 12, there were a bunch of kids in my school who took on, sort of bullying me and taunting me that you're a Jew. And that's when I found out.
Okay.
According to them, I was a Jew. So I didn't know what it meant, but it meant to endure their insults. Yeah. Luckily, there was one classmate of mine, only one, who stood by me.
Right.
And so these kids, they would surround me. If I were alone, they'd probably beat me up. But because there was this friend who was always stand by me. And interestingly enough, he came from the poorest family. He was a very bright guy, but he came from the poorest family. But he had a moral compass, I would say. Many years later, I had the opportunity to thank him for this.
Brilliant.
Because I said, he really did something important for me. So he would stand by me. So these bullies, they were afraid, because I was a nerdy kid, but I was strong, so I could hit back. Okay. And then with my friend together, we would actually
you had the firepower.
beat them back. But that was the first time I found out that I was Jewish.
Okay.
In that sense, that's being different.
But you didn't think this could potentially hold your career back?
I did not at all.
Did Yevgeny know? Yevgeny sounds like he was a man of the world and knew mathematics. Could he not say, hang on, you might struggle here to get into the university? Or did he not know that either?
Well, because we lived in this provincial town, people didn't really know what was going on in Moscow.
Right.
In Moscow, everybody knew.
Right.
But we were kind of under the impression, we thought that why would anybody bother with mathematics? Because it's nothing to do with defense, for example, or anything like this. So we were naive, me and my parents, we were naive. And we didn't know any stories of people who were denied entrance. Okay. We knew stories of physics departments where Jewish students would be denied entrance.
Oh, okay.
And the story was it's because the government is afraid that they would immigrate to Israel with their secrets and take with them the state secrets or something, Okay. But math, who cares about math secrets?
So what happens when you apply to Moscow then? Do you sit the exam and do you actually sit exams? And
there was a written exam, mathematics written exam, then mathematics oral exam, and then there were two more. There was a literature composition, and there was physics.
Yeah.
So the written mathematics exam, I just went and solved all the problems, even though everybody said you cannot solve the last problem. It's unsolvable. But I didn't know I couldn't do it, so I did it,
Okay. And solved it.
I solved. And so afterwards, I came home, and Evgeny Evgenyevich came to our place, and I explained to him all the problems and solutions, and he said, everything's correct. So I was actually happy. I was like, what are these people talking about? By that time, I kind of got a whiff that this might happen, that they would fail me. I got some idea about that by then. But I was in denial.
Okay.
I was very upbeat and kind of like, okay, they're going to give me an A, and I'm going to just sail through.
You'll be the exception because you're so brilliant.
Exactly. How can they fail me, right? So then there was an oral exam a few days later, and that's when crazy stuff started happening.
Okay.
Yeah.
So what they were like saying, solve the Riemann hypothesis.
No, it was in some ways it was much worse because, so first of all, you are in this room with like 20 other kids, right? And you have to pick out a ticket. So it's called like a ticket. It's like a little piece of paper. And there are 2 questions. There is a list of questions which is given in advance. There may be 80 questions. Each student gets 2. I have to answer 2, and then there may be follow-up questions.
Okay.
So I get my ticket, my 2 questions, and then you have to sit down and prepare. And my ticket, and first of all, I knew all of it through and through. Yeah. And those were particularly simple. So after 2 minutes, I raise my hand. I'm ready. And there are 3 examiners in the room, and 9 of them, they all look through me. They don't come to me. So finally I grab one of them. By that time, in like half an hour or 15 minutes, other kids start, raising their hands. One of the guys, I just grabbed him by his jacket, and I said, "Why are you not talking to me?" And he says, "We are not supposed to talk to you." That's when it's like the reality hit home, It's like, uh-oh.
You eventually did get to do it, did you? The oral exam?
So then a special group, special 2 examiners arrive.
Oh, okay.
And they come to the front table in front.
Okay, the bad cops.
And they are like, and they point finger at me. I was the only one, the ostracized one in this room.
Okay.
And then I was like, okay, my inquisitors have arrived.
Okay.
The
men in black.
Much more. So it was, on the one hand, when I look back, on the one hand, really, what a terrible thing to do to a 16, 17-year-old child, And a lot of my friends who went through this, future friends whom I met later, who we shared the same story. So some of them never recovered. So they kind of really suffered from this. Yeah. Because the way it was approached was the worst possible way. So if they actually came to us and said, "Look, you are 50% Jewish. You have blood. 50% of your blood comes from Jewish, family, whatever. And that's why we cannot accept you." So okay, so he was like, "Okay, this is a draconian, unfair, policy, but it's not because I'm not good enough. It's just because that's how it is. So I have to deal with it." That's not what they said, because it would be illegal to say that, because in the Soviet Union, of course, all nationalities are equal.
Right.
So they had to trick you and give you questions which on the surface looked like normal questions, but would be 100 times harder, which they would never give to a regular applicant. And then they would pretend that those were the real questions that they give to everybody, and because you didn't solve them, you're actually not good enough. And that a lot of people, including myself, were traumatized by at some level, So it was really, really tough experience, because my exam was about 4 hours, and I fought with everything I got, Yeah. But there was no way to. I'm not sure how much in my book, Love and Math, I actually describe some of the questions that they gave me,
right.
And there's a lot of testimony about there are actually articles being published with lists of problems. It's actually interesting to see. Now it's a kind of a historical artifact. To what length these people went to be able to deny something to people that they hated for no reason at all. My examiners had never met me. In fact, interestingly enough, after the exam, I happened to be one-on-one with one of them in the elevator, and he was giving me compliments that you're so brilliant, Yeah. So why was he doing that? And to what length to go to do that to somebody you never met, right? To what lengths, how much effort they put to create these problems meticulously. These problems which look like they were called coffin problems for some reason.
Coffin problems.
Coffin, yes, coffin, because they want to put you in a coffin, so with this problem. So it is deceivingly simple, but then, and you can, if you do Google coffin problems, Moscow State University, you'll find plenty of them. If any of the listeners are interested, they can find. I say nowadays, if you don't think too much about the history and what it's actually meant to a lot of human beings, real human beings who suffer tremendously from this, but you just look at it as a mathematical problem, it's actually very interesting. So it's kind of an interesting, challenging quest. Come up with some problems which look like regular high school problems, and yet even professors will be stumped by them. So it's really complicated, really hard to solve. So that's what happened. So, and the end was that I was denied. I was failed.
Did you come away from that experience with what you talked about, thinking, I'm not as good as I thought I was, or did you know they stitched me up. I am good enough, but they've stitched me up here. Which of those two were you?
I knew that they stitched me up. I knew that it was unfair. So
Okay.
luckily for me, luckily.
So almost like your ego was intact almost because of that.
No, actually, it was more than that. I was resolved to prove them wrong. So it gave me that fuel, actually. So,
But what can you do? There's only one university to do this.
yes. So an interesting thing happened at the end of this 4-hour exam is that one of these two inquisitors, and they were so nasty. They'll be like, this is wrong. So like, what is the definition of a circle? And I'm like, a circle is a set of points on the plane equidistant from a given point. And he says, no, that's wrong. I was like, what? Like, how could it be wrong? It's a set of all points equidistant from... Yeah, it's like you didn't put the article in the right place.
Okay, yeah.
And they would be so cheerful about it, like finding this little nitpicking,
Yeah.
But suddenly, after the exam, I told him that I actually want to withdraw my application. They were worried because sometimes people would apply and then they would have to clean up the mess sometimes, so that it's somehow easier for them if the person is broken by this process and they just withdraw themselves.
Okay, yeah.
And not appeal. Sometimes people appeal. There was an appeal process.
Okay.
But I decided not to go through, thank God, because it would be totally futile. And I said, I want to get out of here. And he said, but by that time it's like 7 or 8 p.m.
Yeah.
And I was like, how could I get my application? Because there was actually stuff like documents which I actually left in their admission committee. And he said, oh, it's okay, I take you there. I have a key.
Right.
And so we were in the elevator for a couple of minutes or a minute, just the two of us. And that's when he suddenly starts giving me compliments. And he says, oh, you were so brilliant. How come? And I was like, you got to be kidding me.
Yeah.
But he gave me good advice. He told me there is only one school in Moscow which takes students like you.
Okay.
Like you. And and he gave me the name. It was a university which was called Oil and Gas University, which sounds strange, right? Why an aspiring mathematician would want to go to an oil and gas institute? But this oil and gas institute had a small applied mathematics program.
Okay.
And so I took him at his word because I figured why would he be lying at this point?
Yeah.
And I actually applied, and indeed they did accept me. And moreover, 90% of the kids, it was a much smaller program. They were like 1/10 of the Moscow University math department. But about 90% of my classmates in that school suffered the same fate that I did.
Right. So they had Jewish parents.
Jewish parents were some of them, but almost all of them were from Moscow. So they actually went to special schools and stuff. And so for them, it was even more outrageous. Like I came from this provincial town. So in principle, we could say, okay, well, you come from this provincial town. Yeah. Your knowledge is just not good enough here in Moscow.
You're sort of almost still ahead of the game because now you're at least at a Moscow university.
Right. But those kids, they shared stories, and they are, in some sense, what happened to them was a lot more outrageous.
Yeah.
Because they had classmates, like dozens of classmates who were accepted and whose oral exam would be like 15 minutes, and they'd be like, you're in. And for me, it was like hours, and for them as well. So anyways, so that was how I got a foothold finally in Moscow. And that university was really nice in many ways.
Was it an inferior education though?
No, well, it's not inferior. It was just different because a certain level was really high, and the professors were really great as human beings and as professionals. We didn't have, obviously, the greatest mathematicians, some of whom were at this Moscow University. But also the drawback was that because it was geared towards applied area, some of the hardcore math courses, pure math courses, were not taught. So I had to learn this on my own, basically.
Okay, so there was, again, a little bit of self-education on the side.
Oh, yes, a lot. Yeah. So here's interesting enough, what happened was, first of all, I was lucky to be at this school because, as I said, many of my classmates actually came from the tradition of like really best math education in Moscow.
Right.
In Moscow, there were specialized schools for mathematics. And most of the kids in my classmates, this oil and gas university, were from those schools. And so they had many classmates who actually were accepted to Moscow University, so they could find out about what's going on, what courses, what seminars, and so on.
Oh, okay.
And for instance, one of the kids who was a classmate of several of my classmates, his father was like a great mathematician who was a professor at Moscow University. And he was very kind, and he always welcomed us at his seminars.
At Moscow State?
At Moscow State. However, to get into Moscow State was not easy because the building was guarded by the police. It's funny because I at some point after my book was published, I was interviewed by somebody, and I recounted this part of the story. And the interviewer, she said, interesting. She said, in this country, they try to keep students inside the university. And
You're sneaking in.
In Russia, they try to keep you, the Soviet Union tried to keep you outside.
How were you getting in? Were you having to sneak through back doors?
So because my classmates, they were, clued in, it's like they knew what's going on. So they said, there is a way. So you go on the side of the building where there is an entrance for the trucks, for the cafeteria. And there was a gate which was a little bit crooked. And so you could kind of climb up almost to the top of the and it was big. It was like a big gate, maybe 5-6 yards. You climb to the top, and then it kind of gives you an opening, and then you can sneak in. And then we would walk into the cafeteria, and through the cafeteria, with all this, cooks looking at us like, who are these guys?
Yeah. You're like, where's the mathematics?
And run through the cafeteria and come out and then take the elevator to the...
Wow.
It's crazy, if you think about it. Later on, 2 or 3 years later, I was able to get an ID, a pass to be able to walk through the front door. But you could not get through the front door. There was a policeman.
Yeah.
There were several policemen there. So they would not allow somebody who is not registered as a student. But we found a way, would climb over the fence and go. So I was continuing to meet Evgeny Evgenyich occasionally when I came home, on the weekends.
Yeah.
But basically, it was kind of after a year or two in the school, I was kind of running out of steam. And that's when I lucked out again. So there was again a human being, a generous human being who took me under his wing. And he was a great, great mathematician. His name is, since we follow the Tolstoy traditions of his patronymic name, Dmitry Borisovich Fuchs. And actually, interestingly enough, Fuchs immigrated to the United States about 20 years, more than maybe almost 30 years ago. And he's a professor at UC Davis, not so far away from me. And he just turned 80. On October 1st, on September 30th, and I actually dedicated to him one of my recent math papers. So it's kind of an interesting reminder to me of how much I owe him, and his generosity.
How did you come to cross paths with him?
It was kind of by chance. The whole thing, it sounds really improbable. But there was a professor in my school who kind of took a note of me. And then he was a very good mathematician in his own right, and still is. And he had a problem that he had to solve, which was in the area of topology, which was the area where Fuchs was king. And so that in those days, it was quite common that these people, they all knew each other. So he would ask Fuchs how to solve this problem. And Fuchs said, I don't know, but it shouldn't be very hard. Normally, I would give it to a good graduate student to solve. But since you work at this oil and gas institute with these unfortunate souls who were denied entrance, why don't you find a bright guy in there and give him him or her my phone number so that I could supervise their little research on this in private?
Okay.
You see?
Yeah.
So my professor Fuchs could give it to somebody in Moscow University, but he was mindful of what's going on. And people like him, they wanted to help. So they want to find some little way in which to, at least to help somebody to overcome the system. You see? So for me, it's always like this story, like people say...
Is his thinking, could there be like, a Ramanujan hidden there in the oil and gas? Or is it like, this is sort of cheap, grateful labor, or is he...
Oh, no, not cheap or grateful, for sure not. No, I think it is really a human being, a decent human being, trying to help those who were unfairly treated unfairly, And so to me, it's like people, I talk to all kinds of people, and I always hear this like, the system is so rotten and so on, Yes, it's true, perhaps, But in some sense, that's the system. That's the job of the system, to be rotten. So the job of the system is to block. That's how it's kind of an inertia. So of course, sometimes it takes grotesque proportions, like denying 16-year-olds entrance to university, which is absolutely atrocious and terrible. But by and large, you have to expect that there will be obstacles. So in my case, they were maybe a little bit too much, But all of us meet obstacles one way or another. If you try to do something different, if you try to do something that's not sort of even slightly off the beaten path, sure enough, you will meet resistance. So first of all, don't be surprised. Don't take it personally. And keep going and keep following your heart. Keep following what you think is right. And at some point, somebody will come and appear and open. So I had to climb over the fence.
Literally.
And yet, because I did not give up, for 2 years, doing this in Moscow, there was this man who appeared, and he's like, okay, here is a hidden door. I'll take you.
And you impressed
and
him?
And I impressed him. And I very quickly, I wrote my first paper. So I was 18 years old, and my career took off. And 3 years later, I was a visiting professor at Harvard.
How did you get from writing your first paper at 18 to suddenly being at Harvard? That seems like a quantum leap.
See, but can you imagine? So for me now to speak about that kid, that teenager that I was, can you imagine the drive? Can you imagine how much he wanted to succeed and to prove those people wrong?
Yeah.
You thought I was not good enough. Well, let me show you. Let me show you. And so in that sense, when I look back, of course that having been failed like this brutally, it was a horrible, horrible experience. But yet at the same time, if I was strong enough, then it gave me that energy, that energy and that steel, that motivation to work harder. And that's why you realize that actually these obstacles, they have this twofold. There are two things about it. So yes, it may be something very difficult, and
it would break a lot of people.
And actually could break people too. Yeah. But if you are able to just hold tight and kind of say, no, I'm going to do it, then actually you can turn it around. It's kind of like a jiu-jitsu kind of move,
Yeah.
So suddenly you use that momentum of your opponent to actually propel you to the next height. You use that energy to actually go further that I would never have got. I'm pretty sure I would have never achieved, as much as I did in such a short period of time. Had I not been subjected to this very unfair treatment, where I knew it was wrong, so I have to prove. So that was important. Of course, then, as I said, I owe this tremendous gratitude to my teachers. So it was Fuchs, and then there was another fellow who was his student and his co-author, Boris Fagin, who became my teacher, my real very close collaborator and teacher. And so by fourth year, Fagin and I wrote a bunch of papers, which kind of became well known, shall we say. And based on that reputation, I received a letter from the president of Harvard University, so I'm barely 21, in last year of college in Moscow. And I received a letter on the letterhead of president of Harvard University, signed by Derek Bock, who was the president of Harvard University at the time, 1989, saying, we would like to invite you as a visiting professor.
Amazing. So obviously, does this mean mathematicians at Harvard had seen your papers and just said,
yes,
we've got to get this young guy?
And there were people who apparently had high opinion of me, who kind of also whispered in the ear of those who made decisions. So there were many angels, so to speak, many guardian angels who helped me along the way.
This sounds like a stupid question. I'm sorry if it is. Did you speak English at this point?
It's funny you would ask. I had difficulties, So the first time I went to the supermarket in Boston, I couldn't find salt,
Yeah.
And part of it was that I was overwhelmed by the abundance of food, because in the Soviet Union at that time, in 1989, there was nothing on shelves.
Okay.
Nothing. You had to know somebody to buy from the back door, of a supermarket. There was no such thing as supermarket, actually. There were small shops. Anyway, so I was just I think I was hypnotized by this. I was just wandering the aisles. I was like, what is this? And I tried to ask people, where is salt?
Yeah.
And I couldn't understand what they were saying.
So you could speak broken English?
I could speak. I could give seminars at Harvard. I could talk about my mathematical work. And in fact, I wrote my papers, which brought me to Harvard in English.
Okay.
But my colloquial English left something to desire. Okay. So the way I learned, actually, what was helpful, apart from looking for salt at Boston supermarket, was watching late night television. Okay. David Letterman was king of, as far as I was concerned anyway, was king of late night at the time. And I was watching him religiously. Okay. And then videotaping and watching the next day and trying to play the same sentence several times to understand what is it that he was saying.
So without being too technical, and if it's possible, what is the area of mathematics at this point that you've made your name in? These papers you wrote that were so groundbreaking, and the things that brought you to Harvard. What's this area of mathematics called? The general area, which is the focus of my research, is called the Langlands program, after a mathematician, Robert Langlands. He's a Canadian-born mathematician and is currently professor emeritus at the Institute for Advanced Study in Princeton, where, incidentally, he occupies the office
of Albert Einstein.
Nice.
So about 50 years ago, he came up with these groundbreaking ideas about connecting problems in two different fields of mathematics, number theory and harmonic analysis. And a lot of people got very excited about this, and it sort of became this big area of research. But actually what happened next was even more surprising, that other mathematicians found very similar patterns, similar things in other areas of math, including geometry, and then later quantum physics. So in fact, those who listen from the beginning will appreciate this. My research in the last few years has been on the interface of mathematics and quantum physics.
You got
exactly the kind of stuff I wanted to do.
You got there in the end.
Yeah.
Okay, right. And
it's a Hollywood ending, although it's continuation in some sense.
Did the move to the United States really boost your ability and your career? I can imagine to some extent it might make you fat and lazy. You might think, I've made it. I don't need to prove anything to anyone anymore. What became your motivation to keep succeeding once you'd succeeded?
Right. Well, I guess the spring was coiled so tight, after that exam, that it could last many more years.
That one day, what that one day did for your life?
Oh my God, yeah.
Yeah, the scars of that one day.
Incredible, yeah. And took so many years for me to actually come to terms with, because for many years I was in denial of what happened, so I didn't fully appreciate what a traumatic event actually it had been for me. So it took a lot of pain and sort of difficulties to reconcile myself with that child, that 16-year-old whom I kind of left on that battlefield, which is normal, that's what we do. But if we are lucky, we come back. Eventually, when we get stronger, we come back. And so, and to bring him back and to be more in touch with that reality, and also appreciate that reality also. So it was tough, but we made it. We did well. He and I. And so, but why do it? So I guess it's because I'm really interested. So I'm really. I think as we reach a certain middle age, I'm now 51. So I think it's natural to start asking why do it. So I had this period a few years ago when I actually start questioning, do I actually love it, or do I do it just by inertia, And there was a lot of sort of contemplation of this. It wasn't clear with the answer. And I knew that I was ready to move on to something else if I don't like it anymore,
Well, away from mathematics?
Yeah, I would. It was like, why? And this came with these discoveries of my past, and like I said earlier, really understanding what happened when I was 16 and a lot of other things that happened in the Soviet Union, which some of it was beautiful, but some of them less so, So when I felt much more in touch with myself, and I was kind of more prepared to be honest with myself about what am I doing? Why am I doing this? And also the fear of, I saw how much of my daily life and my research even is driven by fear. So I want to be relevant, for instance. I want to still produce articles that people cite and invite me to conferences and stuff like that. So I'm still relevant, That idea is based on fear. So it's like I'm afraid that you don't remember about me. So who cares, right? So what matters is whether you love doing it or not, right? And so because it's very easy to get just go by inertia. You write one paper, then write the next one, and just go day after day. Writing my book, which was about 6 years ago, it was published, was very helpful because it helped me appreciate more what mathematics really is about, the beauty of it. Because I felt compelled to articulate it for others, and then I articulate it for myself as well.
Yeah.
I remembered that night I mentioned earlier, when I couldn't sleep because of these periodic numbers. I still get goosebumps when I think about it, So there is that thing which is I just love it. I'm curious about it. I want to know, So that's ultimately, I think, is what motivates us, is because we're really curious, because it's such a beautiful subject. Unfortunately, very few people get to see how beautiful it is, unlike art or literature or movies, where it's much more readily available. Mathematics is hidden. So, but more and more people are now doing a good job exposing this beauty to others.
So your book, and I will link to your book in the notes to the podcast, it's sort of, your book seems to have two threads, doesn't it? It's this biographical story, and you want to get some of this stuff off your chest about what happened in Russia and how wrong you think that was, but you've also got this agenda of wanting to talk to people about the beauty of mathematics and how that's not shown enough. What should someone take from the book? What were you trying to accomplish? What was your main goal?
Interestingly enough, so what I discovered through this process is that whatever the author thinks they're doing may not be true, because there could be some unconscious motives which he or she is not aware of. So that certainly was the case for me. Here's how I would describe, if you and I spoke about it, in 2012, 13, when I was writing it. So the analogy I make is, imagine an art class in which they only teach you how to paint fences and walls, but never show you the paintings of the great masters. Then, of course, you will say, I hate art. But in fact, what you would really be saying is, I hate painting the fence. And so it is with mathematics, that we teach our students as if to teach them how to paint fences and never show them the mathematics of the great masters, right? So, and for me, being exposed to all this, I just felt ashamed that we mathematicians are not finding ways. Of course, it's more abstract than art in some ways, So, and there are no museums already now, although now more and more math museums appear as well. I felt this urge to share. I thought it was such a shame. I was really ashamed that I'm not doing enough. So it's like, here's what I'm going to do. I'm going to write this book, and I'm going to let other people see that beauty that I can see.
So you were going to showcase some of the masterpieces?
So, yes. But how to do it? Because I understand it's difficult.
Yeah.
And I tried to do it other ways, and I could see how difficult it is. So I decided to wrap it in a personal story as a kind of a trick to show this kid who is so excited about the subject, and then he faces obstacles, has to overcome them, and yet he has this drive. But why? Because he finds it beautiful. But what is about? So the reader would then come across this and say, what did he find so exciting? And that's when I will explain.
Yeah.
And the reader would be well motivated to listen.
Because there's a character they want
There's
to
a character,
empathize.
Right? It's a story. And yes, so that was the idea.
Yeah.
But what I realized later is actually I had to tell the story to myself also. Because a lot of that, I knew this as in a third person, not in the first person. I did not fully actually identify myself with that kid who was ruthlessly treated, unfairly treated at that time. So as I was writing it, it brought me close to that, to myself, right? So, however, interesting enough, when I was writing, I think who was writing? It was the 16-year-old who was writing. So, and I think this way I was able to connect to the readers. It was not Edward who was, in his 40s at the time who was writing, but no, I was not yet communicating with my 16-year-old, but I allowed him to write, to speak, his voice to be heard through the book, because I wanted the book to be successful, you see. And so interestingly enough, through this process, I got to know him more. And so soon after the book was published, I was actually able to see more clearly, not at a conceptual level. Oh, there was this guy, I went there, I sat there, and I did this, I did that. But actually to feel the pain which he felt, it was tremendous amount of pain.
So do you think the book's greatest success is its ability to tell the story of the pain of Edward's journey, or do you think its success was showcasing the masterpieces, which is what you set out to do?
But how can you separate the two? You see,
when people talk to you about it, what do they want?
Both.
Okay.
So, but sometimes, interestingly enough, because sometimes I think the way we communicate with each other. So for example, sometimes somebody can be touched by a story because it may actually remind them something about themselves, but they may not be ready yet to frame it in these terms. But yet they can be drawn to it. So then they may contact me and speak about how they were fascinated by the mathematics of it. But sometimes I can actually feel that actually there's more. So sometimes it is just a straightforward interest in mathematics. But usually it's more than that. I think that it touches upon some, one could say, archetypal, things in our, because we all have to overcome and we all have to go through pain and suffering. And, so in that sense, just like mathematics is universal language. So Pythagoras' theorem means the same thing to everybody, right? At any time, x squared plus y squared equals z squared. That's why we love mathematics, is because it brings us together. But so do these personal experiences, because when you tell me about something that you had to overcome, that you were mistreated and so on, and yet you were able to succeed, that you failed and then you were able to succeed, I am with you at this moment because it reminds me of something that happened to me. And that's how we also find that we are not that different from each other, right? So in that sense, these two parallel tracks are they are meant to be together because they are there to remind us of who we are ultimately.
I have to ask you about one other artistic endeavour of yours. This is your controversial Can I call it controversial?
Yes.
Your controversial film, which I have seen, which means I've seen a lot more of your flesh than I may have expected when we first met. Tell people about what this film is, how it came to be, and what happened. Yeah.
Well, so first of all, this is a crazy kind of thing. So now in retrospect, so it's been 10 years since this film was made in 2009 in Paris with a group of really amazing, dedicated people, most of all with my co-director, Ren Graff, who's a French film director. This was really crazy project. And I understand it now more clearly. Again, I did not understand at the time so much. But it was sincere. It was a sincere effort. That's what matters in the end. I wanted to do something different. I wanted to break out of the kind of... I felt, a little bit my life to be too circumscribed, too constrained. And of course, a lot of it was not so... I'm not proud of, for instance, narcissism of it, in some sense, which kind of comes through a little bit. So I want to be this guy on the screen. And of course, I did have these aspirations to be seen, my naked body and so on, So, okay, I admit it, of course. But it was not only that. So there was more. And so I was actually criticized for this film.
Can you describe, like, just in a nutshell, what the film is for people who are unfamiliar with it, so that it makes more sense?
Okay. Well, I mean, in some sense there are spoilers, but okay. So at this point, I guess it doesn't. Whoever wants to see it, it is available, by the way, online on a very nice website called labocine.com.
Okay.
First of all, it's a homage to a Japanese film by the great author Yukio Mishima, who also himself played in his film.
Right.
Which was called Rights of Love and Death, and our film is called Rights of Love and Math. So that came before the book. In fact, the title of the book was a riff on the title of the film, but they're unrelated. Although they're related by the idea of trying to show mathematics in an unconventional way. In the case of a film, the idea was to have a mathematical formula not written on a blackboard but tattooed on a body.
Yeah.
And I think actually it's a very good idea by itself, because it kind of shows you that mathematics gets under your skin. So it kind of shows this visceral character of it. So that a story of a researcher, a story of a mathematician, a truth seeker, if you will, it is a romantic story in some sense.
I tell you what as well, Ed, you were before your time, because these days when I meet young people and mathematicians, everyone has mathematical formulas and things to do with mathematics tattooed on their body.
Well, thank you for saying that. So to me, it was just an insight. It was just this, boom, it just came to me. And I was collaborating with this amazing French film director, and we were bouncing ideas for a few months in 2009 about how to make a film where a viewer would be just we wanted to shock the viewer a little bit. To just present mathematics in a way which nobody ever had seen it before. And then suddenly I was like, you know what? What if we have a tattoo of a formula? And so then one thing led to another. And then we came up with a story, and it's a kind of it's a fairy tale. It's a kind of a mythical story. And it is actually unfolding on a stylized stage of a Japanese theater. So it's a homage to this Japanese film, although the story is totally different. The premise of the film is that a mathematician, played by me, of course.
Yes.
A mathematician finds a formula of love.
Right.
So what happens next? Right. So he is elated that he has found the source of eternal love and beauty. But of course, and youth, But of course, the formula has a flip side that can be misused. It can be used for evil. He discovers it quickly. And now he is being chased by this sort of evil people that are not specified. But actually, 10 years ago, I saw that, which many of us are very much aware now of the dangers of mathematics, through surveillance, through... actually, the very first Numberphile video I did was about the NSA putting a backdoor in a popular encryption algorithm, right?
Yeah.
So some years before that, I was already kind of interested in this idea that mathematics could be misused and used for evil.
Yeah.
Also, artificial intelligence and all this stuff, right? So now it's very much in the media, in the news, and so in the public domain. At that time, it was not so widely discussed in 2009. So that was one thing I was interested in. So he's being chased, but of course, there's a woman. There's a woman he's in love with, and he wants to make a tattoo of this formula on her body. Now, a lot of people took this literally, and they were offended by this because they said, why is a mathematician a man and his love interest is a woman? I think a lot of people who complained, most of them actually did not see the whole film, but maybe a trailer, and maybe they got slightly the wrong idea. But I think if they see actual film from beginning to end, and it's only 26 minutes, I think they may actually see that it's not... how to say, it's not so trivial, So yes, I agree, and I am kind of in retrospect, maybe it would make more sense to reverse the genders.
Okay,
because I personally think that and I'm not just being facetious, but I really mean it. I think that underrepresentation of women and minorities in general in mathematics is the single most important problem that we have to deal with, because a lot of other things are consequences of that. And definitely we have to make an effort to bring more young women and minorities to mathematics.
Yeah.
And be more, not just bring, but be supportive, be compassionate, be aware of the plight, of the difficulty of being a minority. So it's not something to say as a slogan, but something that requires sustained effort. And so having said that, the film was very personal for me.
Yeah.
And I see now it more clearly, because actually I was both that man and that woman. So because in the end he kills himself, but she, at the end of the film, she actually rises with that formula on her belly.
Yeah.
So that was me. I wanted to be reborn. That feminine side, which I had felt perhaps suppressed for many years, it wanted to burst out. So for me, it was very personal. So the gender role distribution was a consequence of that very, very personal character of this film. I could not articulate it at the time. Actually, I understood this later. Some people, interestingly enough, some viewers saw it right away.
Yeah.
That what I was talking about. I did not know it. I understood much later. And I saw very clearly that this was my desire, my wish, to become more whole, more myself, to know who I am, to become more whole and more at peace with myself. And that included and required, in fact, reconnecting to my feminine side also. So that woman, in my mind, in that film, that was me. That was that part. You see what I mean?
Yeah.
And so, and of course, who is she? So the whole thing is a fairy tale. So we don't have to take it literally. She is mathematics herself. She is the truth. And in fact, there is a painting on the wall which says the truth in Russian. So there's a lot of stuff which is woven into it. And I would just invite anybody who comes across this film not to rush to judgment or to conclusions, but try to see it and try this to speak to you not in conceptual terms, but in more visceral terms. And see what you come out with. And of course, nowadays, we are so quick to label things and so on. And so if somebody wants to label, then maybe it's not for them, this film. But I think somebody who wants to contemplate, who wants to see what is it like to experience something. Because for us, it is like a tattoo. For us, because tattoo is painful. I actually don't have any tattoos myself.
Yeah.
But I know people who have. And so it's painful. But so is discovery in mathematics. It doesn't come for free. Nothing comes for free. You have to make an effort. And it's a metaphor for that it gets under our skin and we carry it with us. Like a baby, one could say like a baby that who is made on the belly, So it's like his baby, he's dead, he's gone, but he survives in that formula, which is eternal.
In the film, Edward's character does the tattoo. And it is an actual formula.
Yes.
Does it mean something? Or?
Oh, yes, it does.
Right.
And it is from quantum physics, of course.
Okay.
It's from one of my research papers with my two good friends, physicists, Andrei Losiev and Nikita Nekrasov, two Russians, brilliant physicists. When we were making the film, the question arose, which formula? So, of course, we don't want to do something cliche like E equals MC squared, which is already well known. And then I was like, continuing this narcissistic streak, I was like, I want it to be my formula for one of my papers.
Yeah.
So I did a casting so I was literally like leafing through my papers to find something which kind of looks nice,
Okay.
Captivating, not just meaningful, but also because actually, if you look at it, a lot of people kind of like were touched by it. I think at least I got a lot of comments just that still image of the tattoo on the body. It's like wow, So if I felt if I wrote the formula on a blackboard and tried to explain it, most of the audience would walk out. But here I think people could feel that energy of it. That it's not. Spurious, it's not superficial mathematics, it's not devoid of passion, it is not separate from our lives. It is actually a product of passion, a product of love. Everything that we do with our heart, is something that is meaningful and something like a work of art, in some sense.
Was it one of the more obscure formulas, or was it like a key plank of one of your
It was a very important formula from our paper. Oh, yes, definitely.
Okay. It wasn't just like a footnote on page 8 looks nice.
No, I'm very proud of this formula. And I think it still hasn't been fully explained, actually.
Has it got a name?
In the movie, it's called Formula of Love.
Yeah. What's it called in your paper?
It has a certain numbering. I don't know, 5.17 or something. But
okay.
When I have shown the film in various film festivals and stuff like that. So invariably somebody would ask, so is this the formula of love?
Yeah.
So
how do you feel when you watch the film now? Because talking to you, I get like a feeling like a feeling that you're proud of it, but there's also like regrets or things you would do differently, or like how do you look at it now?
I had a very complicated relationship with it, so I kind of didn't like it when it was for many years. I was uneasy about it. And it is a crazy thing, I cannot believe I did this, honestly. I mean, it's really crazy. But I am proud of it. And I hadn't watched it for a long time. And then a couple of years ago, I watched it again. And it suddenly hit me what it was about, And it was kind of an emotional moment for me because when I saw what was unspoken. I was not ready to I was not consciously aware of a lot of things happening inside me, and they spilled over on the screen, in this way, in this weird way. It is a weird film. I mean, there's no question. So
there's not a lot of talking in it for people who think
it is silent.
It's a silent film with music,
with Wagner, with Richard Wagner's Tristan and Isolde. My God, it's incredible. That music, and to have that. But we owe that to Mishima because his film also had Wagner score, although a different recording and different parts of the opera. But there are a lot of interesting things in there, hidden things. So one day maybe I write a book about it because there are so many references which are, I think, people who may not even be able to realize. So I have a complicated relationship with it. The way I see it now, one could argue about its merits and so on. It's an unusual film. It's a weird film. But it was something that was necessary for me at the time. Without this film, there wouldn't be my book. Without it, I would not be able to understand certain things about myself.
We often hear, mathematicians do their best work when they're young. We have the Fields Medal for under 40-year-olds and things like that. Is your best work behind you, or is your best work ahead of you? But also, is your best work mathematics or artistic? Because you seem to like doing the arts and the math stuff now.
Well, I sure hope my best is ahead of me.
Yeah?
I might be not actually, interestingly enough, a lot of people know me not from my research, not from my book, but from my Numberphile videos.
Well, then I hope your best work is ahead of you.
That's how I might be remembered, actually, Brady.
Well, you need to make more Numberphile videos then.
Perhaps. And so, I don't know. I mean, I was just, I gave this talk in July. There was a public lecture in Sweden, and I was quoting from a great compatriot of mine, Sofia Kovalevskaya, who was a Russian mathematician, and she was the first woman mathematician who in Western history, Western civilization's history, as far as we know, who was a university who had a PhD, was a university professor, was an editor of a prestigious mathematics journal. That was in the second half of 19th century, and in Sweden, in Stockholm, she was. Even though she was not allowed to take courses in Germany, for instance, she was a student of the great German mathematician Weierstrass, but he had to teach her privately because, being a woman, she was not even allowed to sit in, let alone be registered. So of course there's some parallels with I can see some parallels,
Yeah.
And so maybe that's why I feel certain kinship with her. And she was by the way, also a writer. She was a great writer. She wrote a number of books which were successful, and she died at a very young age. She was barely 40 from tuberculosis, unfortunately. But absolutely brilliant human being, and mathematician, writer, and everything else in between. And so she wrote in a letter to somebody that you cannot be a mathematician without being a poet at heart. A poet is someone who sees things differently, sees farther than others, and that's the job of a mathematician as well. And I was really struck by this. And when I was giving this lecture in July, And then I kind of blurted it out. I wasn't preparing to say that, but I said, actually, you don't have to be a mathematician to be a poet, so anything you do that really comes from something deep inside that you really care about, something which we say from the heart, but maybe it's a bit overused, this expression. So let's just say from passion, that you're passionate about, something you're passionate about is poetry. That's what it is. And so it's so easy to forget. So a lot of my math is I would say is poetry, but some of it is not. So, and it's okay, So there are certain things which are routine and so on, so I kind of do. But there are certain bursts of inspiration, and I think we live for that. And it doesn't have to be math; it can be, it doesn't have to be even a profession. It could be something in one's personal life, helping somebody. That's passion too. That's poetry. And so, in that sense, I don't really care anymore, I guess, if I remembered as a mathematician or whatever, or if I'm remembered, it doesn't matter. So it's more like, do I do the right thing right now? Do I do something? Do I follow my passion today? So, for instance, I come to this to speak to you, Brady, and honestly, I say no to everybody these days. Like, there was a time in my life when I was super interested in being on the stage and being like, getting accolades and applause and so on. I really don't care. So I care when it is meaningful. And so I know that you do really incredible work with Numberphile, and I deeply appreciate it. So when you give me this opportunity to speak, I said yes without thinking, because it's just I feel like part of the family of Numberphile. Yeah. Oh. And so it's a pleasure to speak, And so that's to me an example of something I did today, which was from the heart, was from the passion, So it's real. Then it's real, and I can sleep well tonight,
What's the thing you're chasing now, though? Is there something in the Langlands program that I won't understand? Like,
yes.
So there is. What's motivating you in your passion for mathematics now? There is a result out there you want, or
Yes. So there is this new version of Langlands program which I'm working on now, kind of a new strand, if you will, like a DNA, new strand with two great colleagues. One of whom was actually my classmate in Moscow in this oil and gas place, believe it or not. But we never collaborated. He's a professor at MIT. His name is Pavel Etingov. And the other one
sounds like that oil and gas university produced some pretty good mathematicians.
Oh my God, yes! If you look at the list, it was like, wow, there's some really. Yeah. I'm really proud to be from that school, and it's a separate story that I'm really grateful to that university, and it was not easy for them to do what they did. They gave us home, and which was really, really nice. But and the second co-author was one of my mentors when I came to Harvard. He's now a professor in Jerusalem. His name is David Kashdan. So it's a very exciting project I've been working on with them for the last year. And just this morning I spoke with David on Skype. He's in Israel. I'm here, so it's like it's really exciting.
Are you winning that battle or losing? Who's winning against?
We are going. I think we're doing great. I think we are there. Yes, we keep progressing.
I have one more question. What happened to Yevgeny? Did you stay in touch with him?
Yes, we have been in touch, by email. I haven't seen him in a long time.
He's still alive?
Yes, he is. Yes. His health was not so great recently, so I'm keeping my fingers crossed. But
he got to enjoy your success.
But he read my book where I speak about him. Yeah. And he was happy about it. I say sometimes that my book is a love letter to my teachers, It's like, that's really the real heroes in the story.
For more about Edward's work, and of course to check out his book, see the links down in the notes. I'll also put some links there that Edward has recommended, other stuff you might want to read or see. And of course, I'll also put a link to Edward's Numberphile videos. This podcast was recorded at the Mathematical Sciences Research Institute, which is a great supporter of Numberphile. And we'd also like to thank our episode sponsor, Maya Sound. They're an audio engineering company, also based in Berkeley. Have a look at the notes for more links. I'm Brady Harron, this is the Numberphile podcast, and we'll be back in your feeds again very soon.